So in trying to show you how to do virtualization, or well, really how virtualization works from a basic perspective, I have put together a VMware ESXi server, and I'm just going to show you around. I really want to show you what a virtual machine looks like and what the interface looks like. And I'm using VMware ESXi as an example of that. I just want to show you what it looks like, and my environment is going to be set up in here as well. So let's take a look. Here is what is known as vCenter Server, and I'm going to add a new virtual machine to this box. And I'm going to add a typical virtual machine, and I'm going to make this my client 01. I'm going to click Next. I'm going to put it on that local store. And this is going to be a Windows 7 machine. This is going to be a Windows 7 32-bit machine that I'm going to be putting on there. And I'm going to attach it to my external network. And I'm going to click Next. I'm going to thin provision it, and I'm going to make it 10 gig. And I'm going to click Next. I'm going to edit virtual machine settings. Now here is everything so far, most everything, that the hypervisor understands and is able to deal with. And if I select Show All Devices, I'm able to see the keyboard, the SIO controller, the mouse, the video, the IDE devices, and so on. But I'm going to be dealing with RAM, and I have a 512 megs of RAM I allocated to this. I allocated one processor to it, and I have allocated a 10 gig drive to this box. There is already one network card that's going to be attached, a SCSI controller that's going to be attached. I'm not going to be sharing any bus type, so it's SCSI controller that's attached. Floppy that I don't really care about because I haven't used it and I don't really know how long. CD, DVD, I'm going to need this. I'm going to go over to Data Store ISO device, and I'm going to point it to where my Windows 7 operating system ISO file is. ISO file, for those of you that don't know, is what is going to contain the installation image to boot into Windows 7. So there's that, and I'm going to click Finish, and it's going to create a Windows 7 machine right here. Now, of course, nothing's in there right now. I've got other machines here, these jump machines. I'm going to click on Client 01, and it's going to be starting it. It's going to start the Client 01 machine. As you see right here, Power On Virtual Machine on the bottom. And it just started Client 01. I'm going to open up the console, which is that right there. And the console will show me the Windows 7 installation in progress. There it is right there. And what all I have to do is I have to walk through the Windows installation as if this was a physical machine. Nothing real special about it. The virtualized hardware takes care of communicating with the physical hardware for me. So I don't have to worry about pointing this thing to any kind of processor or anything like that, and I don't need to do anything special. Right? This is going to install like a normal Windows 7 machine, and I'll be able to walk through the installation. So here it is. I'm just going to click Next over here, Install over here. Here it is. The setup is starting of Windows 7. And as the Windows 7 setup starts, the virtual hardware, the hypervisor, is taking care of communicating with this virtual machine and presenting it with the proper components. So here is Windows 7, and I'm just going to click Next on the top one. So this, I'm going to accept the license agreement, click Next, and I'm going to do Custom, and I'm going to do, so it says right here that Windows can't be installed on this disk. I think I know why. Okay, so I need more space, right? So what I'm going to do is this is one of the pieces that is very, very simple inside of a Windows machine. Okay. So inside of a Windows box, I can do this. I can click on the inside of a virtual box. I can turn the power off. Say yes, and that turns the power off. And I can go to the VM hardware and go to Edit Settings. And I can go over to my options, and I can specify that this is a 64-bit version of Windows 7, right? Not Vista, but Windows, like so. And I can go over to my hardware resources and my hard disk and change this to a 20 gig hard drive, and I can click OK. Nice and easy. Okay. And once I do that, I just power this thing back on, and it's going to start to recognize my new 20 gig hard drive and my 64-bit processor that I allocated to this. Well, I told it that I'm going to be using a 64-bit Windows 7 machine, and I'm going to be installing on a 64-bit hardware. And I gave it 20 gigs of disk space because 10 gig wasn't enough. Now, if this was physical hardware, imagine what I would have to do. If this was physical hardware, I would have had to power this machine down, add in physically more disk, and this was a 64-bit edition of my Windows 7 machine, and I had 32-bit processor. What would I have to do? I have to get a new processor. So much simpler process here. Here's the Windows installation starting, and I'm going to click Next, and I'm going to click Install Now. And this time around, it's not going to give me any problems associated with hard disk space. I noticed that this was a 64-bit edition of Windows, and I had selected a 32-bit Windows 7 machine as far as when I made the selection for the operating system. Here it is. It's a 64-bit, as you can see. And I'm going to click Next right over here. Accept the license agreement and click Next. And I'm going to do a custom build. And I'm going to click Next. Notice, no problem. It recognized the 20 gig. Okay, right there. And it's going to begin the installation process of, there it is. Okay. So that's Windows being installed. It's that simple. Very, very easy to install the Windows operating system. Okay. Or really, Linux operating system would work in a very similar manner. All I would have to do is I would just need the ISO file, which is the DVD file that will allow me to install a version of Linux, whether it be SUSE or Ubuntu or CentOS or Red Hat or Fedora or any version of Linux I would have, and I'd go ahead and install it. Very, very simple to do. So there I was installing Windows 7 inside of my hypervisor. In this case, my hypervisor happened to be VMware. It could just as well have been Microsoft or just as well have been Citrix. And this is a few things here. There's the full virtualization, which was the first generation or first gen of virtualization, which offered x86 or x64, 64-bit virtualization. You had your hardware, then you had your host operating system, right? And then you had emulated hardware. And on the emulated hardware, it was emulating device drivers. That emulated hardware is really taken care of. And all of the hardware is emulated, including the processor. Okay? And virtual machines had a guest operating system running on it. And then you had applications that were running inside of the guest OS that were relying on these device drivers to communicate with the emulated hardware, which was communicating with the host operating system, which of course was communicating with the physical hardware. Okay? The advantage of emulation or full virtualization or Gen 1 was that there was this emulation layer isolates the VM from the host OS. There's complete VM portability. Okay? The consistent set of system hardware is being emulated across the board. You're able to move from one type of hardware, let's say Intel, to another type of hardware, let's say AMD, without any issues. Okay? So that was emulated hardware. Now the problem is there were a lot of issues associated with this as well. The Gen 1 virtualization or full virtualization, the OS kernels were expected to run in privileged ring 0. Now ring 0 is the internal kernel of any system. And ring 0 is a protected environment. Only the operating system runs at ring 0. You may have heard of kernel mode and user mode that exists in every system. Kernel mode is really the ring 0 or the innermost component of a particular machine. User mode is where the applications and such and what the user communicates with is executed. So ring 0 is controlled by the host OS. Okay? So VMs are forced to execute at ring 1, or ring 3, which requires a virtual machine monitor to trap and emulate instructions. Okay? And as a result, there were major performance limitations because of this. So you have the virtual machine monitor, which would be running at ring 0. Then you have the guest OS, which would be running at ring 1 and 3. And then you have the application that was running at ring 3, which is the outer layer. Now, the closer you get to ring 0, you are at what's called kernel mode. The closer you get away from ring 0, or the further you get away from ring 0, you are at user mode, or least privilege to most privilege. Ring 0 is most privileged mode because, well, you're able to seriously manipulate the way the machine is operating and behaving. Then there was para-virtualization, Gen 2, where you had your hardware, you have the device drivers, and you had a hypervisor on that layer. And then you had virtual machine monitor with a specialized API or specialized set of instructions. Okay? And then on these specialized set of instructions, you would have your virtual machine, and you had your guest OS, and within that, you had your applications. All right? Still, the device drivers were communicating with this specialized API and the virtual machine monitor, or VMM. And then you had that communicating with the hypervisor, and then that communicating with the hardware. Okay? Now, VMM, the virtual machine monitor in this particular instance, is responsible for handling the virtualization requests, okay, and putting them to the hardware. Okay? And because this guest OS is modified, which is what ends up happening in para-virtualization, the guest OS itself is modified. It is fully aware of how to process these instructions. And the privilege instruction translation by the virtual machine monitor is not necessary, and the guest operating system utilizes the specialized API to communicate with these device drivers. Okay? So VM guest operating systems are para-virtualized in two different approaches. There's the recompiling of the OS kernel and then installing the para-virtualized drivers. Okay? In some OSs, it's really not possible to use a complete para-virtualization. Okay? You do this recompiling of the OS kernel where the API has to reside in the OS system kernel. This is really not done so much today. Then there is this hardware-assisted virtualization, okay, where the guest OS is running at ring 0, this right here, okay, is running at ring 0, and virtual machine monitor uses extensions such as Intel VT, or VT stands for virtualization technology, or AMD-V, which is AMD's virtualization, to intercept, okay, and emulate privileged operations in the guest. Okay. Hardware-assisted virtualization really removes many of the problems making these VMM issues go away. And VMM runs in a more privileged ring than 0, and a virtual 1 ring is created as a result. So hardware-assisted virtualization. So you have the VMX, a virtual machine, in a non-root environment, and then you have the VMX in a root environment. Okay. So least privilege is a green, and most privilege is this pinkish red. Kernel and ring 0 exist here. Okay. In a hardware-assisted mode, hypervisor runs at ring 1, and which is a super privileged mode, so that the virtual machine can run, well, really unmodified. It allows you to run unmodified OSs. Legacy systems can be run without any issues. Okay. Speed and flexibility. Well, the virtual hardware, your Windows 7, Windows 8 machines and such, or Server 2012 machines, will be taking advantage of virtual processor and virtual RAM, which are not as fast as physical RAM. But today, we're dealing with very, very fast processors, multiple processors, and a lot of RAM on servers. Hundreds of gigs of RAM, and in some cases, terabytes of RAM exists inside of servers or server hardware. So it's not as big of a deal in terms of processor and memory causing performance issues as it used to be. Today, server hardware provides you with a lot of resources. Okay? Then you're able to extend the virtualization concept to desktops. So you have servers, you have desktops, and then you have application. You can virtualize servers, you can virtualize your desktop OSs like Windows 7, Windows 8, and then you're also able to virtualize applications, if you will, as well. Okay? That has and lends itself to a whole lot of benefits. Virtualizing desktops, virtualizing servers and applications, or your application virtualization or installing it, causes your organization or manages and allows your organization to manage hundreds or thousands of machines, desktops, or dozens of servers with a great deal of ease in a separate place, in a single environment, in a single centralized management console. Let me go back to my virtual machine, my Windows 7 virtual machine that I left hanging over there, and I'm going to show you how I can complete that install.
Start with new learning now.